Okay, so previously we did some of the concepts, right? The first thing was, okay, we started with the electric field. Okay, we discussed the concepts, okay, simple concepts. And then we talked about the type of the electric field, okay, and the uniform and the non-uniform. And we were discussing the non-uniform field, right? And the non by like if you want to look at how the non-uniform fields look like, so it is something like that. Okay, it varies as you move on. Okay, and if we discuss the properties, so these are the three properties that I wrote. Okay, and after that we were on the Coulomb's law, and we have to discuss the concepts of the Coulomb's law, and we did some of the concepts of it, right? And now we have to move on to something. Okay, move forward. Okay, so basically, in the previous class, we discussed all of the things till the Coulomb's law. Okay, and now we also discuss the formula for the Coulomb law. It's up to you. You can use any of the formula. Either you can use this formula or you can use that formula. Okay, the two formulas are related by this constant. Okay, where k is equals to 1/4 pi epsilon naught. Okay, where epsilon naught is going to be your permittivity. Now, if we try to compare the value of the electric field strength, like how strong it is, so for that we can use the same concept, the same formula given. Okay, so let's imagine that I have these two charges with me. Okay, like the proton and the proton, and these two protons are like separated 1 millimeter, 1 nanometer apart. Okay, and 1 nanometer is like you can consider. Okay. If you imagine a nucleus, so nucleus is basically 0 0.1 nanometer in width. Okay. So approximately the nucleus is this much of a width. Okay. And it contains a lot of proton, right? So this 1 nanometer distance for the proton is like the very huge distance, right? So it's like thousands kilometers or at least 1,000 meters for like 2% maybe if you assume it so. So if we try to find out their charges, so their electric force, so we can use the formula E is equals to, okay, F, come on. Okay, so F is equals to Q over R squared, right? And we okay, if we substitute the values, so the value for the k is 6 point sorry 8.99 exponent 9. Okay, and the value for the charges, since both the charges are the same, so you can directly square the charges, right? 1.6 exponent negative 19 and you whole square, right? And divided by the separation is basically 1 nanometer, so 1 exponent negative 9, okay, is squared, right? So can you please give me the value? Yes, anybody? Sorry. Yes,
The answer is
yes.
2.3 into 10 to the power minus 10.
Okay. So you are saying the answer is as 2.3 exponent negative 10, right? And this is Newton and this is force. Oops, sorry. I have to go here. Reduce the transparency. And okay. Now, so this is a simple concept. Now, if I try to make two charges, right, and these two charges are, let's say, one millimeter, these two charges are 1 coulombs, okay, and they are 1 millimeter, 1 meter apart, okay. So if we try to find out the value of the electric field, okay, so by applying the same formula, F is equals to K Q Q over R, okay, and putting it the value the value is 8.99 exponent 9, okay, and every rest of the things are 1, okay, so you'll get the force as just the same as the value of K, right? So 8.99 exponent 9, right? Newton, right? And this is like a huge force, right? Um, and this huge force corresponds to a concept or a comparison between the electric force and the gravitational force, right? So we can say that the electric force is basically, okay, still not working. Okay, so electric force is basically, um, it is like the strongest fundamental force out of all the forces that we have, right? So strongest uh, fundamental force out of all the forces forces we have. Okay, okay, right. And you can even perform a comparison as well, right? Since we only discussed the electric field and the gravitational field, so if we imagine, um, or if we try to find out the gravitational field strength of the two proton, okay, so we can simply do, okay, we can simply do mm, Fg is equals to Gmm over R squared, right? And 6.67 exponent negative 11, right? And if we consider the two proton having the mass of 1.66 exponent negative 27, 1.66 exponent negative 27, and since we have two of them, so divided by the radius as 1 exponent negative 9, okay, and you have to square it, right? So can you tell me the value for the gravitational force, please? Is anyone? Any value, please?
1.8 into 10 to the power minus 46.
Okay. So you were saying 1.8 exponent negative 46 Newton for gravitational force. Right. So if you compare the two values, okay, these are the two values. The first one is this one, okay, and the second one is that one, right? The magnitude of the electric and the gravitational field, right? Gravitational force. So basically, they're like huge. Like there's a huge difference like between the two values, right? So you can see it is negative 10 and this is negative 46, right? like the difference of negative 24 power, right? Fine. So that's why. So this is weakest of all the forces, right? Now, after studying the concept of the electric force, we have to understand the concept of electric field. Although we did some of the things regarding electric field previously. Okay, but like these are the reason. Okay, we wrote the formula as well. Okay, and from now on, we can do we started with the formula E is equals to um, F E, the little e for the electric force, okay, and this is the Q, okay, and we found out or we work out that the electric force having the formula F is equals to KQ over R squared, right? So you can substitute that back in. So KQ over R squared divided by Q. Okay, so this Q and that Q goes off, and you'll be left with E is equals to KQ over R squared, right? Where please keep in mind where Q is basically the source charge, okay? The charge that creates a magnet electric field, okay? Um Source charge, okay? And R is the separation between the two things, right? And you can also write this formula if you want to replace K with its actual value, which is 4 pi epsilon naught. So Q over 4 by epsilon naught, right? And you have R squared. Clear? Okay. So these are the two formulas that you can apply. You can apply any of the formula, okay? Every time it should give the same answer. If you're not getting the same answer, it means there's a problem with your calculation, right? Now, moving on to the Coulomb's law, because all of these things are basically related with they're basically related with the concept or with the calculation of the Coulomb law, right? Now, if we try to write down the okay, if we try to write down the definition of the Coulomb law that is required in your syllabus, so the Coulomb law is basically so it is a electric force experience by any charge. Okay, I'm just putting the bracket around because this is not required by the way. Okay, so electric force experienced by any charge is directly one proportional to the product of two point charges and inversely proportional to the square of the separation, right? So this is a concept of the Coulomb's law, right? In this concept, you should point out the first this thing, okay, as being 2 point charges. Okay, this is very important. Okay, and inversely proportional to the square of the separation, right? Not the radius, the separation. Okay, So these are the two very important things that you'll get the marks on. Okay. And now we have the assumptions that we have to make while writing this thing. Okay. So the first is, okay, is it on the top? Yes. So the first one is basically um, um, charges must be point in nature, right? This is the first thing. Okay. And point in nature means that is all the charges should be concentrated toward the center. Okay. This is the first thing, right? Now, the second thing is, oh, okay. The second thing is charges must be considered as point charge. Sorry, must be considered as spherical in nature, right? This is the second concept, right? So if you consider the charge as being spherical, then you are allowed to use this formula, okay? Or the K1 or this the other one, right? So this 4 pi, this constant 4 pi is basically due to the sphere nature of the charge, okay? Now the third is going to be uh, at least one of the charge should be stationary. At least one of the charge should be stationary, right? If in our case we consider both of the charge stationary, right? Both of the charges being stationary, right? We don't consider any charge as moving because otherwise it will create a problem for us, right? So both the charge should be stationary, right? Or at least one of the charge. If both the charges will be moving, then the electric field will be different, okay? And this formula, like the Coulomb's law formula, will be applicable there, okay? And okay, spherical, fine. These are some of the assumptions for the Coulomb's law, right? Now, since we consider that the electric field strength around the charge is basically it can be increasing or decreasing. It basically decreases as you move from the surface to the far point, but inside the sphere it remains zero, right? Because we are considering the charges to be concentrated at the center, right? So if the charges are concentrated at the center, then it should be zero any other point other than the center, right? So now if we move on to this part, okay? Now we have the gravitational field strength due to the charges, right? I've drawn one of the graph for the positive charge, okay, and I'll be making it for the negative charges, okay. So let's try. So I just want this thing for the negative charge. These are basically the distances we are taking, okay, but this thing need to be smaller, and it should be right here. Fine. Okay. And I have these distances, right? So always keep in mind the first thing that the electric field strength remains zero inside the sphere. Okay. So this is the first thing that you need to remember. Okay. So electric field strength remain zero inside the sphere. Okay. And electric field strength decreases inversely proportional to the square as you move on, right? So let's imagine that I have this surface. Okay. This is, let's say, 2r. Okay. The surface will always be at r, right? And this is, let's say, 3r, and this is 4r. Okay. These are some of the distances we have, right? And assuming that we have the gravitational field strength 1, 2, 3, 4, 5, 6, 7, 8. Okay, right here. Okay. So this value is E naught, right? Let's say E naught can be 1 to anything, right? It depends upon the chart, right? You can work out for that, right? And E naught by 2 would be half of the boxes, 1, 2, 3, 4, right? So this is E naught by 2 or 0.5 E naught, right? So there should be 3 E naught by 4, right? 0.75 E naught. Okay. And then there should be E naught by 4, right? Which is 0.25 of E naught, right? And before that, there would be value decreasing till 0, right? Now, if we try to plot the graph, so the first point is going to be from the surface to the radius, okay? And this is the first concept, right? Where you have the maximum electric field, okay, at the surface of the sphere, okay? So this is the first thing, okay? It will, electric field will always be maximum at the surface, right? And as you move on from one point to another point, so from R to 2R to 3R to 4R, the E value will change, right? And its change depend upon the similar thing that we studied in the previous class, okay, of the gravitation, right? So imagine that if I have the formula, okay, now we know that K and Q are both constant, right? So we are only left with E and then R squared is equals to K and Q, right? So since K and Q for any specific value remain constant throughout the concept, right? So I can replace it with the K and the Q for the other value, okay? So E2 R2 squared should be equal to K2, right? So now I can say that R1. Now I can say that I can equate the two formulas and I can say that E naught times HV is equals to, hmm, Come on. If I write E naught times R1 squared, which is in the form of R, is equals to E3. Okay. You can first do for E2 and then R2 squared. Okay, but you'll get the same answer, right? As of the first one. So E naught is going to be E naught, okay, in the form of E naught, and at the surface, this sphere has a radius R1. Okay, so E naught and then R squared is equals to जो E2 है, that is this portion, okay, and this is going to be um okay. So at the 2R distance, it is going to experience a lesser amount of electric field. Okay, so its formula will be, by the way, E2 is equals to R2. Yes. Okay. So I have E naught and then R squared divided by, come on, divided by 4R. It should be 2R because we are working at 2R. Okay. So 4R squared is equals to E2. 4R now goes off, and okay. So E2 is basically E naught by 4, right? So your second point is going to be right here. Okay. Now, this is your second point, right? Which is E naught by 4, right? And you can do the similar working for E3 and E4, right? So for E3, you can say that E naught by 9, okay? Because you're working for the third value, so third value gets squared and then it become 9, okay? So it would be right here. That is 0.25, 0.9. 0.125 is basically in the center. Okay. Now, at that point, this has a value of something around 0.111. Yes? Okay. And then, yes. So basically, it would go 125. It should be even smaller than that value. Okay. Come on. It should go a bit lower. Okay, so this is the third point. And for the fourth point, you'll again have to do the similar working, and you'll end up getting the fourth value of R as being E is equals to, come on, E is equals to E naught by 16. Okay, is that clear? And E naught by 16 means 1 over 16 is basically right here. Why it is a circle. Okay, so these are the 4 points. If you want to join them all, so you can join. It should be all in that. Okay, now these are the calculation, and this is the formula. Electric field strength remain zero inside this layer. Okay, and you can also say that it will be maximum at the surface of this, and then it decreases. Okay, so these are the concept of the graph for the electric field. Okay, and this is also known as the inverse square law, right? So inverse square law is basically the point where your object start following the g your y equals to 1 over x squared, right? This is what we call the inverse square law, right? Okay, so this is done, and inverse square law is also called y is equals to, what the hell, man? It should be y equals to 1 over x squared, right? This is what we call the inverse square law. Inverse square law, right? So basically, over here, you can see that the electric field and the distance are following this law, right? So and this law actually show you how your field is when you are near to the planet or near to the charge, and how your field will be when you move away from the charge of the planet, right? So it basically increases or increase or decrease drastically after a certain distance, right? Because it is the squared in the denominator. Okay, and this is what we call the Coulomb's law, right? And the electric field strength. Okay, now I'm keeping this class till this point, okay? Because from now on, we have to discuss one of the graph, and then we'll move on to some of the potential concept, and then we'll be left. Probably it take 1 more week to complete. Okay, so but that's it for today. Inshallah, we'll do the class tomorrow, and we'll discuss some of the more concept for this chapter. Okay, so that's it for today. Take care. Allah Hafiz.
Yeah.
Allah Hafiz.